Probably not talking to me. Yeah, this one? You're talking about
Yeah, considering. All right, guys, so let me make sure I remember which section it's going to be on. Yeah, I think I said it last time. 6162. Yeah, so it'll be section 5152, 6162. The quiz that's happening tomorrow. All right, guys, do you have any questions from homework? Yes.
Can you do 70 and 84 from 6.1?
I don't know. Let's find out. 70? Okay. Ooh, I like it. So, one revolution of any circular shaped object would equal how many radians? 2 pi, because it would go completely around. 2 pi radians. One revolution would equal how many feet, inches, or whatever that equals. Well, one revolution lengthwise is the same thing as the circumference, whatever that is, right? So this is kind of like an idea of angle that it's turning through, but you could also think of it as an idea of length it's traveled. So if your car travels forward a length equal to the circumference of your tire, you're going to end up at the same point. A little piece of gum is there, and you roll forward one circumference worth forward, then the gum is going to be back on the ground again, right? You're not going to see it. You guys kind of with it. There's a tire, there's an alien tire. Oh, let me pull forward a little bit. I don't see it. Let me pull forward a little. I don't see it. No, dude, go half as far forward, and then you can see it. Has that ever happened to you?
That's how they figure out if you move downtown. They chop your tires.
I know, exactly. So you just got to know you pull up a little bit, and they won't see the chop. Anyway.
You chop the bottom of your tire to see if you move downtown.
I mean, have you ever seen them do that?
Those time spaces.
You park in a 2-hour parking place, and some person comes by and does this little flip. And they're just putting a little line on your tire that will wear off over time. And then they come back to see if you've been marked. If it's 2 hours later, like, time to give it to you.
Yeah, you haven't moved. But if you move,
if you move, most likely it won't end up in the same place. They won't even know that it's been marked. Right? All right, another thing. So this would equal blah, 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 whatever the circumference is. All right, these two facts might be helpful. So what's it say? How many revolutions will a car wheel of diameter 30 inches? So they tell me the diameter is 30 inches, and they want to know how many revolutions. As the car travels a distance of 1 mile. So here's the idea then. How many revolutions? Well, first off, so considering that these two are true always, one revolution of anything circular is 2 pi radians, that's the angle. One revolution is also equal to whatever that thing's circumference is, if you want to talk about it in terms of distance traveled. So there is a distance traveled here, right? So what should I find out about my tire? Circumference, that kind of makes sense. What's the circumference? It's 2 pi r, which is also known as pi times d, because the diameter is twice the radius. You guys remember that? In fact, that formula is where pi came from, of course. You take any circle, you take a circumference, divided by its diameter, you always get the same number. Civilizations went, holy shit, and all that kind of stuff, and blah, 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 here we go. History of the world right there. So what is the circumference of this tire? It'll be pi times 30 inches. So let's leave that as 30 pi right now. At the end, we can approximate it if we want to. A general rule for math and physics and science in general is you don't round a damn thing to the end. All right, well, that's nice. That's that many inches, right? So if I went forward in this car, here's the piece of gum. There's a piece of gum. So if I went forward 60 pi inches worth, where would the gum be? If I went forward 60 pi inches in my car, it'd be in the same place, because every 30 pi inches, it's going to come back to the same damn place, right? If I went 60 pi inches forward, how many revolutions would my tire make? 2. You did the distance you traveled. How did you get 2? Tell me, you did the distance you traveled. If I went 60 pi inches, that's the distance I traveled. How did you get 2? You divided by the circumference. So there's a distance I traveled. Probably get the number of revolutions. I'm going to divide that by
35.
Yeah, the circumference, just like we just did, right? All right, so now you got to figure out is 1 mile is how many inches? We might have to be a little more specific. Right? I don't know what a lot is divided by 30 pi is.
6360. It's a little bit less than a lot.
No, so 1 mile. What do we know about 1 mile? Somebody know a damn thing about 1 mile? 5280 feet. Yeah, let's not go to a unit of measure that makes sense. Let's stick with this thing for this problem. Yeah, beautiful. And then, of course, multiply by 12 to get how many inches it is.
23,360.
And whatever the hell that is. And then you take that number divided by 30 pi to see how many revs. Because every 30 pi inches you move is 1 revolution. So how far did you move? Blah, blah, blah inches, whatever that is. So you divide that by this to see how many revolutions there are. It's kind of mind-blowing to think how many revolutions your tire's taking as you're traveling like up to LA going 100 miles an hour. Right? If you do that. Is that decent? But do you see what I did in the middle of that problem? I said, that's going to lead to an ugly number. Let me make the number really nice. In fact, let me make the number a multiple of this. And then just see what my brain does to answer the question. So if I went forward 60 pi inches, how many revolutions? Oh, that's easy. I do 60 pi divided by my circumference. So in general, I do distance divided by, you can do it, Jeff, circumference. Screw it, you know what word that is. Equals number of revs, number of revolutions. That's most freakadelic. If you think about it, it only makes sense. If let's see. If I had a circle of circumference 7 feet, and I said this circle has rolled 8 times, so it made 8 revolutions, and there's a little bug stuck on it. He's alive, don't worry about it, he's alive, but he's stuck there. How far did the bug actually travel total? Yeah, see, you did number of revolutions times circumference to get the distance the bug actually traveled. So that's just this formula worked around with, right? All right, cool, maybe. This is not a formula that's going to sit on any page of formulas. This is a formula that we created to answer this question. Okay, cool. So don't try to look, where's the formula for this? No. You got to think what makes sense. I create it for myself as I need it. Anything else from homework? There were other hands, yes.
Number 35 and 5.2. So 385.
Oh, okay. So, of course, we we need to be at the point where if I ask you, what is the sine of 120 degrees, I'm working my way towards your question. I'm working my way. If I ask you sine of 120, you should be able to think for less than a minute, maybe draw a little picture. Can you figure out what that value is? Good. What's 60? Why'd somebody say 60?
180 minus 120.
Because if I go 120 degrees, what's the reference angle? 60 degrees. That's how far it is away from 180, right? That's the reference angle. How far from the x-axis it is. Is sine to be positive or negative? Positive. So it's equals the same thing as sine of 60 because that's the reference angle. And what's the sine of 60? No, not what I didn't say what's 60 in radians. I said what is the sine of 60 degrees? This is root 3 over 2. Why is the bigger dude? Because sine likes y, and 60 is close to the y-axis. The further you get away from it, the smaller sine gets. Right? Because it gets scared. It doesn't like. It's like, I like y. Oh, shit. And it gets all tiny. All right. So finally, getting to Franklin's question. He's sitting there very patiently, like that had nothing to do with it. So you should be at this point where if I give you the angle, then you have to give me the actual value. So then let it be nice if they actually give you the terminal point. The terminal point would have, for this case, would have been if they would have said, what's the sine of something where the terminal point is this? Well, the sine is root 3 over 2 because it's the y piece, right? Okay, so you guys with me? So if they tell you the terminal point, good Lord, Jeff, you normally can't write today. You really can't write. Terminal point was, I forgot where it went.
513.
There it is. They tell you this is the terminal point. And then they ask you what's sine of t. Well, that relates to which part of that? Yeah, the y pound. Yeah, it's negative 12 13ths. Because sine likes y. Sine is the y piece of the terminal point on the unit circle. Right? And they tell you the terminal point is given. Yeah, why do I know this is on the unit circle? They don't really tell you that, so you got to be careful. How do I know this is on the unit circle? That's not good. Yeah, I'm sorry.
X squared plus y squared.
Yeah, and is that true? You sure?
Looks like it.
Yeah, it should be.
Yeah, so if you square this, you get 25 over 169. Square this, you get 144 over 169. So sure enough, you get 169, which is 1. Yay. But be real careful. Most of these should have said in the directions that this is actually on the unit circle. I think it looks like all these are, but you want to be sure. Right? Alright, so sine t is this, so cosine t would be negative 5/13 because cosine t is the x piece of a terminal point on the unit circle, right? And the tangent t is just y over x. Yeah. 12 over 5 because the over 13 and the negatives cancel. You guys with me? So you start to be able to identify the easy questions versus the harder questions. You don't know yet in the beginning because you're just figuring out everything. But now identify that as an easy question. You didn't know going into it, but that turned out to be an easy question. Cool. Anything else? Yeah.
84A for 6.1.
Oh, 6.1. So is this the other tire?
Yeah, it's 442.
Oh, okay. So I kind of left it to you to read up about angular speed. But it kind of makes sense if linear speed is how fast, how far in feet or whatever you go per second. Angular speed will be what angle do you turn through per second, for example, right? So angular speed is how quickly you progress how quickly your angles grow over time. How quickly you go through them. So angular speed is given the symbol, let me make it more freaky, omega. It's like a W that's kind of curling up. It's like a spider you've smushed. It's curling up on itself, right? So omega, or you can make a freaking W, it's fine. Equals the angle divided by 10. So that's how far you've gone in degrees or radians per time. And normally it's going to be radians. We want it to be real. Okay, so that's what angular speed is. So they tell me, let's look at, and in fact, your question was actually on part. What was your question on?
A.
Well, that's good. Because we're going to look at part A. Part A says, it says a truck with a 48-inch diameter wheels is traveling at 50 miles an hour. Find the angular speed in radians per minute. That's awesome sauce. Right there's what that is. So do you notice a couple of places you got to be careful with units here?
Inches versus miles.
Yeah, one part is in inches and the other part's in miles, so we probably want to make those agree. The answer wants to be in minutes, and this rate they give me is in hours, right? So we probably want to do something about that. So we can attack this. Now, if you have a different way to do this, do it that way. I love it, but let me show you this way real quick. Changing hours to minutes is easy. Right. Or where do I put hours so that it cancels? On the top. I'm going to go straight from hours to minutes, because how many minutes in an hour?
60.
That's insane. And then miles to inches we just did a minute ago, right? So there's 1 mile. And why did I put miles down there? Yeah, there. Stop that, Jeff. Evil. Hours go away. Miles go away, and I want to take that to feet. 5280 feet. And then I want to take feet away to inches. So 12 inches in a foot. So now if I do that, times that, divided by that, I get my rate in inches per minute. Not a normal rate. Hey, how fast you going, Bill? Oh, 10 inches a minute. You're weird. So, let's see, what is that? 5, 6, 2, 10, 5,000, or 52,800?
Yeah.
That is equal to 52,800 inches per minute. So if you ever hit 50 miles an hour, just realize you're going 52,800 inches per minute. Very freaky thing to consider. So do that next time. How fast you going, man? 52,800 inches a minute. You weren't specific. All right, so the minutes match now. Do you see how this kind of feels a little bit like the problem we just did earlier? But there's no mention of revolutions here, right? So I don't care about the revolutions necessarily directly this time. But what I want to figure out is how many radians I'm traveling per minute. So I want to convert this 52,800 inches into radians. And so to do that, I can do it several different ways. But one circumference equals how many radians? Yeah, that's always true, right? It's sort of the same thing as one revolution, but now I'm going to say it like a circumference. One circumference worth of travel is 2 pi radians, because it's one revolution around. I'm going to let that sink in for a second. How are we doing so far? It's weird. You've never talked about it like this before in your whole life, but it makes sense if you think about it. These have to be true. So what is a circumference worth? How many inches?
48 pi.
48 pi, that's correct. That equals 2 pi radians. Right, so let me see if you guys can handle this. Therefore, 24, what is this, inches? Equals 1 radian. Is that cool? Do you guys see that? Can I just divide both sides by 2 pi? So I'm playing around with this conversion. So if somebody told you, hey man, 24 inches is 2 feet. You know, like, well, yeah, but what's more useful is freaking 12 inches is 1 foot, yeah? Okay. So, I mean, any conversion that you have, you can adjust it. So I'm going to make this as easy as I can. Every 24 inches that I travel is 1 radian's worth of angle measure on my car tire. With my, hopefully not my car. I'm not tumbling down the road. Sorry. Do you see the connection here? Everybody see what I do next?
Divided by 24.
Do who do what?
Divide the 5,000.
Yeah, I want to see how many of these fit in there. So I divide, and every one of those is a radian. So I just divide that by 24 inches to figure out how many radians that is.
You got 48 pi by these, plugging in 48 for the...
Yeah, one circumference is 48 times pi, right? Pi times d. So that's 48 pi for that wheel. And I don't care how big or small the circle is you're looking at, one circumference will be 2 pi radians because you've gone all the way around them, right? So that's always true, that first statement's always true. So we just put the specific circumference in there, and then I can connect it to how far the car is actually traveling per minute. If you've ever taken chemistry, you might realize that this is purely a conversion problem. This is you don't even really have to understand any of it. You don't even have to know what the hell an inch is. This is purely a conversion problem. All right, good. All right. Anything else from homework? Okay. All right. I want to do one problem with you guys, and then I'm going to unleash you on this thing, which culminates in a trip to Mount Doom. Anything that culminates in a trip to Mount Doom sounds good.
Isn't that where we have to take the ring?
Second?
Isn't that where we have to take the ring?
You have to take the ring.
That's
Exactly.
how we get this.
Just don't forget the ring.
Don't forget the ring. Oh, sorry. We're here. Where's the ring? Shit, it's still sitting on that thing back in the elf place. Oh, shit. That would be awesome. Yeah. Get the eagles out there early. All right, let me see. Let's see. Let me do this like this here. I'm going to do this together with you. And this, I could couch this in a word problem. I could say somebody's flying a kite, and the angle, and this is what would be called the angle of elevation. Elevation. You see in the textbook, you see angle of elevation, angle of depression. It's always from straight out. It's always from horizontal. So if I'm in a plane, and somebody's down here motioning to me, I would say the angle of depression to the person is this much. From straight out, down. So if I'm walking, looking up at Mount Doom, the angle of elevation is so much, right? And the closer I get to something, what happens to the angle of elevation? It increases, because you go, oh, shit, right? As you get closer. And then you like pass it by. Oh, okay, all right, good. Let's not go there. So let me call these things some things. See, now the easiest part of this question is what? Yeah, the only angle left that you don't know is that one. How big does it have to be? 62 inches, right? Because these two have to together make 90, so that together with this 90 it makes 180. Because we're in Euclidean geometry. And non-Euclidean geometry doesn't have to equal 180. But we won't go there. Why did I say that then? Huh? Just blow your mind. So yeah, so now that we're in normal geometry, that's 62 degrees. And now you can use either angle you want to set up trig functions. So what's one trig function I could set up to get y? All right, 11. So I can use that guy. I can say sine of 28 degrees equals
Y over 11.
beautiful, y over 11, right? Because in general, sine of an angle in the base is the y side over the hypotenuse. This is what I meant by trig functions are relationships between angles and ratios of sides. I know I've been saying that forever. But this is an immediate consequence. If we didn't know trig, there ain't no way in damn hell Pythagorean theorem comes in and goes, you don't know enough. Well, yeah, I can't help you. Right? Because that's how it talks. So how do I get y?
11 times sine of 28.
And whatever that is. So make sure that your calculator is in degrees. Learn from Jeff's past mistakes.
5.164.
5.164?
Mm-hmm.
What?
1.
No.
Oh,
Feet, sorry. So I was like, what do you want from me, man? Now, here's a really cool way to look at this. I'm going to say this, and this will help you if you don't have to take anything else in this class, it will help you. But if you have to take physics especially, it will desperately help you. Trig functions, sine and cosine, are very much like a percentage in a lot of ways. Because what's the largest that either one can be? 1. And negative just really means it's where it is, right? So like percentages can only go from 0 to 1, 100%. Sine and cosine can do the same thing. And what's really cool is 11 is totally here. So the sine is like the percentage of 11 that's in the y direction. Do you see what we did there? Sine 28 times 11. That percentage of 11. I love looking at it like that. It's not perfect because sine is not a linear thing, so it doesn't really relate exactly to a percentage. But it's good enough to think of it that way. It really makes a lot of sense. So in physics, it's a lot of, here's a vector going there, break it into its xy parts. And you think about it like sine is a percentage in the y direction, bam, bam. Right? So how do I get the x piece? Well, the x piece will be a percentage of 11, and what's the percentage?
cos of 28.
Cosine 28. Now, if you don't like that, you could just start cosine 28 degrees has to be, what's a cosine of 28 have to be? It has to be the x piece
Over 11.
over the hypotenuse, and then you would multiply the 11 up and you'd catch up to us, right? I wish somebody would have told me that way earlier in my math and physics career, because it just desperately makes sense, right? So, whatever that is. 9.712 feet? Look at that. Let me learn from earlier. Let me say feet. Make this guy happy. You good? Do you see why it's not a percentage, though? Because this plus this is more than 11. Of course it is. It's not a linear relationship, but it's a decent analogy to think of. It's not a true percentage, but it's a good analogy to think of to make it make sense.
Why did you use 28 degrees?
For
For the cosine. I understand why you did it for y, but why?
But no. I want you to realize, if this is in the base, then this side is related to sine of this dude, and this side is related to cosine of this dude. Now, if I wanted to use this guy to figure out this guy, then sine of 62 would be x over 11. Well, double check it. Does that still come out to be the same answer? Some of us are like, yeah, but actually do it. Try it.
Yeah.
Of course it does. And let me take that further. Because this is something that, a connection that I often forget to really point out, but it should make total sense at the moment. What's sine of 60 degrees? Because it's close to y. What's cosine of 30 degrees? It's the same. So whatever the sine of 28 degrees is, it's going to be the same thing as the cosine of 62 degrees is. Or vice versa. I kind of do that the wrong way, but right? Cosine of 28 degrees will be the same thing as sine of 62 degrees, and you can try it out in your calculator, which is basically what you just did. Because again, they both start, so if I'm looking at it like this, sine starts at 1 here and cosine starts at 0 there. So by the time, did I say that the right way? No, Jeff, 1. So by the time cosine this has gotten to 28 degrees, and by the time this has gotten to 62 degrees, they're both equally far away from where they're 1. So they're both equally going to be smaller than that. Does that make any sense at all, I guess? And that's why this is not an amazingly amazing thing. What's really cool about this, it makes sense mathematically, and it makes sense visually. If I just turn the freaking triangle, I can use that guy instead. Beautiful. You almost can't go wrong then. I will say this. This was not a very difficult problem, so I trust the fact that that's right, so I can do that way. If I had a more difficult problem where I had to discover more angles on my own, I'm going to use the angle that they gave me every time because I'm not 100% sure about the angles I found. Does that make sense? So that's why I almost always just default in general to using the angle they gave me. Because even this, I could have thought it was 72, like I think I heard somebody say, and then I would be screwed. So I would rather only get that wrong and everything else right because I used the angle they freaking gave me. Does that make sense? Use the thing you know is right. Okay, cool. All right, go with me. So with all that, I'm going to give you this handout. This reviews what we did yesterday, and like I said, it's got the Hobbit problem. What do you do with